Good afternoon, everyone. Good afternoon, everyone. Welcome to class number 22 of Advanced Course in Drones for Development. And with this course, we are entering today's Monday and we're entering the fourth week of our course, and it's been an amazing journey so far. Thank you so much for keeping your patience and your excitement up so long, and it's really helping me to put up this course so well for you. Thank you so much. And I really thank my friends Amit and Saksham for helping me out in this course. And I would really thank all the speakers who have helped us throughout this entire month to make this happen, for coming to our course and speaking about their histories and sharing so much with all of us. Thank you once again to everyone. So today we are going to talk about something very different. So far we have discussed about the use of drones for a lot of terrestrial applications, I would say. And terrestrial would mean the forest, the disasters, and we spoke about healthcare, and we spoke about agriculture. Today we're going to talk about today, tomorrow, and day after tomorrow. I think 3 days, three different topics on the water bodies. So as we know that 75% of the earth is made of water, and we are only dedicating about 3 days for water bodies. And so I'm sorry for that. But then, yeah, this is an interesting topic. And probably drones and remote sensing and other applications have been really useful in understanding the water bodies and the life which lives under these waters or over these waters. And so today we are going to speak to my mentor and my friend Karen, Dr. Karen Joyce from Australia. I met her in Philippines for our course on for GMAP's course, and where we were trying to understand how drones can help in STEM education. We will be talking about STEM education on the last day of our course, but today we'll be talking about what Dr. Karen does as a researcher, as a scientist, for her for her research on marine life, and her work has been focusing on coral reefs largely. And she has an amazing story to tell us. She is so impressive in her personality and in her well balanced way of life that I, as a person, am totally impressed by her. So today we are going to hear her, and I request Dr. Karen to please unmute yourself, put on your video, and the class is all yours. Thank you so much, Dr. Karen.
Wonderful. Thank you so much for the introduction, Dr. Ruchi, and it's wonderful to be here with everyone this evening for me here in Australia, and I guess this afternoon for many of you if you are in Nepal or India or other countries around those regions. In Australia, often when we start presentations, we like to acknowledge our traditional custodians of the land. So for me, the area in which I live, which is Cairns in North Queensland, and I'll show you that a little bit later, the traditional custodians of our land are the Jabuganji people, and I'd like to pay my respects to their continuing connection to land, water and community, and I pay my respect to the elders past, present and emerging. So it's always really interesting in Australia, like I said, when we offer our respects to the traditional owners of the lands who have been in Australia for 40,000 years or more, and it's really important that we acknowledge that. So I've got a lot of things that I'd like to talk about this evening or this afternoon with you all, and I'm really keen to jump right into the presentation, and then also to chat with you all afterwards. So please, if you've got any questions as I go along, if you pop them in your chat, or if you want to write them down, and we'll just jump right in, and then you can ask me at the end of my talk. So I'm going to get going. I'll share my screen. So perhaps Dr. Ruchi, if you can just let me know if it doesn't work for me as I go through learning how Google Meet here.
We can see your presentation.
Excellent. All right. Well, to get you into presentation mode now. Great. Okay, so just before I start, I would like you to just pause and have a think about what question you would like me to answer that has something to do with drones and coral reef mapping. So just take a moment to have a think of anything at all that's in your mind about what you would like to know about drones and coral reefs. And what I'd like to do is hopefully at some stage throughout my presentation, I might answer your question. And if I don't answer it, then you've got a question already written to ask me at the end of the presentation. All right, so just take 30 seconds or a minute to write down something that you would like to know about drones and coral reef mapping. I'm going to pause for 30 seconds to let you have a think about that. All right, so hopefully everybody's got something in their mind that they would like to know about drones and coral reef mapping, and hopefully in the next 20 minutes or so, I might answer some of those questions, and if not, let's get to them towards the end of the talk. So before I jump right into it, I just wanted to mention the Sustainable Development Goals. So if you haven't become aware of these throughout maybe this series of talks or elsewhere in your workplace, we look at these 17 Sustainable Development Goals that are really our goals to try and work for a better world. And of those 17, I particularly work with these few. So obviously you can't work with everything, and I'm going to present a range of different things this evening or this afternoon that's going to touch on some of these particular goals that I work towards personally and professionally as well. So my work is all about location. I am a geospatial scientist. And so if you haven't heard of that term before, I'm actually not surprised. It's kind of a technical term, but it really means that I'm interested in location. So that may be something that you're actually more used to knowing about than you think of, even if you haven't necessarily heard the term geospatial before. So perhaps you have a fitness tracker that you wear that lets you know how far or how fast you've run or walked throughout the course of the day. Or maybe you've used an app on a mobile device that lets you know how you can get from point A to point B in the most efficient way. Perhaps you've even jumped on Google Earth and looked at some satellite imagery to check out a holiday destination or what your house or neighbourhood look like. And I'm sure many people that have ever installed any form of app on their mobile device are really familiar with seeing this pop up here that's asking you if you would like to enable location services. And this is because location is key to so many things. But the difference between what I do as a geospatial scientist and what the general public usually does is that instead of just consuming geospatial information, as you are if you're using any of these apps, is that I create it and I analyze it as well. So that makes me a geospatial scientist. And I have been working in this field or the discipline of geospatial science for just over 20 years now. So mostly I started working with satellites. So I'm really interested in how we can see the Earth from space. So this is what you might see on Google Earth. And my job is to make maps of this, to have a look at how things change in the environment. And the reason I started in this field is because I realized quite early on as an undergraduate student that to make the best maps of the environment, you need to get out in the environment and check it as well. And so I realized that I could actually get paid to go scuba diving or snorkeling on the Great Barrier Reef, or perhaps camping in some of our really beautiful national parks that we have here in Australia as well. So I thought that was a fabulous way that I could get paid to do something that I really enjoyed doing. And so for the rest of the talk, I actually want to share with you part of my story that is really all about the Great Barrier Reef. And so this is a satellite image that you see. It's from the MODIS sensor, so it covers really, really large areas. And if this is the coast of Queensland in Northern Australia, and here's the Great Barrier Reef. Now, the great thing about the Great Barrier Reef is actually that it is great. It is absolutely huge. So it's made up of about 3,000 individual reefs. So it's not just one reef, but it's 3,000 individual ones. And if you put them all together, that's about the size of Italy. So it's a really, really large area. But I'm going to take you down all the way to the southern part of the Great Barrier Reef, and this is what it looks like if we zoom in with a satellite, and in particular to this reef here. So this reef is called Heron Reef, and this is a reef where I've spent a lot of time over the past 20 years, and it's an absolutely beautiful place to go, and I feel really privileged every time I get to go there. But so for some context, it is about 11 kilometres east to west and 4 kilometres north to south. And this is a satellite image that you see here as well. So you might think that that's relatively large, but remember that this is actually only 1 in 3,000. So we have so many of these individual reefs around the place. Now, to get you a little bit better acquainted with what the reef looks like, the blue areas around the outside are deeper water, so anywhere up to about 10 metres or so. You can see coral around the outside, so they're the browny parts around the outside of the reef, and some deeper water on the inside of the reef there as well. And over on this western part, we have an island. So part of that island is national park with lots of trees. Part is a resort where you can go and stay for a holiday. And the other part is a research station for the University of Queensland, which is where I do all my work. I'm going to take you into this little spot over on the western part of the reef here. Now, if we zoom all the way in, this is what this image looks like. And this is the best available commercial satellite data. And one of the biggest things that I'm interested in when I look at the Great Barrier Reef is trying to figure out how much live coral we have. Because with everybody so concerned about climate change, we need to understand, are parts of the reef dying or are they actually growing? And the only way that we can answer that is if we can have the right baseline information to start with. So this is what we see from a satellite. And it's really, really challenging to understand if you can actually see the live coral or not. You can see patches of sand, but is the other parts live or are they dead? I ask you to have a think about that and see what you think for yourself. But if we use a drone instead of a satellite, let's see how much better the detail is. So the satellite that you see is up at about 600 or 700 kilometres up in the atmosphere, whereas the drone here, we're allowed to fly up to 120 metres or 400 feet in altitude. So we start to see a lot more detail, and we can zoom in even more than that. And now you can actually see, yeah, all right, so around the edges here, all this brown stuff, that's actually live coral. And there's a lot of dead stuff in the middle, which is actually perfectly normal because this is the corals grow out. If you imagine like the way a tree grows and its stem or its trunk gets broader and broader as it grows older, the coral's quite similar to that. And as the middle part reaches the sea level, then it will start to die off as well. So these are perfectly healthy coral colonies, but you can see the live coral on the outside. And just for further context, this is what it actually looks like when you're in the water. So you can see the live coral around here. This is a beautiful branching coral and some of the dead coral up the top there as it's reached its limit of where it can withstand the water depth. But so you might ask, well, if you can get this amazing information when you're in the water, why do we need drones or satellites anyway? Let's just always go diving and snorkeling because that's the fun thing to do anyway, right? But the big challenge with that is that field survey is just never enough. So this is one of my colleagues swimming along here, and he has a long bar. And on that bar, there are 3 GoPro cameras attached to that. And they're individually taking photos. So in the same way that a drone would actually take photos as it does a survey, Javier is swimming along. And as you can see, as I bring the drone further and further away from Javier, he's so tiny here. And you can start to see his buddy swimmer coming in behind him. He's tiny, so tiny. And then you get the feel for the real size of the reef here. And you just imagine that if this is Heron Reef that you're seeing, you can see all the way back to the island now. And Javier was such a teeny tiny swimmer there. So the information that he can get on the reef is just such a really, really small snapshot. So we really do need to be able to scale that information if we're going to try to figure out what's happening on the entire Great Barrier Reef or even just the entire Heron Reef. And so that's where drones and satellites are really, really powerful. And so ultimately what I'm trying to do is see if we can figure out how much live coral we have, right? So we can see a drone image here and you can see areas of sand and there's lots of coral around as well. And let's see if my animation is going to work. Let's go one back. Here we go. So you'll see this flicking now between the original drone photo and a classification. So basically anywhere where you see those dark green bits, that's where the computer has decided that this is live coral. And that's the area that I'm most interested in compared to the other components. So rock is some dead coral, then obviously we have some sand. And because of the angle of the sun, we also have some sun glint there as well, which is a little bit annoying, but we can remove that as well. So part of the work that I do is to have a look at, well, if I can work out from one photo where the live coral is, how could I teach the computer to understand what live coral looks like and therefore to be able to pick it up in other photos as well. And so here you see on this screen now, we've done this in a couple of different areas on the reef, and now we can get a photo and decide what the percentage live coral is within that individual photo. And then we can start to apply that over larger areas. So every one of these shades of green little rectangles along the reef is where I've flown a drone and taken a photo and then run a computer algorithm over that to estimate the amount of live coral that we see there. So you can see just here off the eastern part of the island, there's quite a bit of live coral. There's lots of algae in this area generally. And most of the high areas of high coral cover are just along the crest here. So all the way these dark green patches. And so we can start to see, all right, if I have a photo and I can run an algorithm over it, perhaps I can now figure out how much live coral there is on certain parts of the reef. And we do this all through computer programming. So this particular project was done by one of my students, Katie Bennett. She was working on this for her master's class. And one of the reasons that we wanted to use open source coding to create the maps here in this project is so that anyone can use it. So anyone can actually use her script to classify areas that they're interested in out of certain drone photos, which is really, really exciting because it just starts to mean that instead of some of this knowledge getting tied up in proprietary software, anyone with an internet connection is able to do this for large data sets. And ultimately, this is where we want to get to. So this is the entire group of reefs. So you can see Heron in the middle there and the other reefs surrounding it, and then ultimately all of the Great Barrier Reef to map what the different habitats are like using satellite as well as drone data. The reason that this works with drone data and photography in general is because everything is about colour. So, for example, this is a really healthy coral that we see here. And you can see it's sort of brownish in colour, so that's within the tissues of the coral skeleton itself. It hosts a little pigment called zooxanthellae. And that's like the chlorophyll that you have in trees that allows it to photosynthesize, so it has food to eat. And what we have, if the water temperature gets a little bit too high for the corals, they decide that those zooxanthellae are toxic to them. And so they spit that out into the water column. And what you see in this process of coral bleaching is now just the skeleton. So hopefully you can see two very clear colour differences between the picture on the left, which is healthy, and the picture on the right, which is not so healthy. And so colour is really, really important to us. And we can actually measure the color of the coral or the color of anything in the environment using what we call a spectrometer. So you can see me in the picture on the left-hand side. I've got a little spectrometer in my hand, and there's a big cable up to the boat there, and that's measuring the amount of light coming off that particular coral. And we've fitted a similar instrument now to this drone that you see flying over on the right-hand side. So it's much, much smaller that you see on the drone because this is a recent spectrometer, and this one is about 20 years old. So you can see these sensors are getting smaller and smaller as the technology is getting better. But they both allow us to do the same thing, and that's to measure the amount of light reflected and absorbed, which tells us information about colour. But to understand that concept a little better, I want to give you an example of how we look at this. So when we're interested in colour of different features in the environment, we call them spectral signatures. So to step through this, because it's a little bit of a technical side of things, I guess, on the x-axis of this graph here, you've got wavelength, so from 350 to 800 nanometers. So our eyes are able to see between about 400 and 700 nanometers, and we're sensitive to blue, green, and red. Now on the y-axis, there's the amount of light reflected by anything that we're measuring. So the first example I'm going to give you is a tree. So let's say that this is a healthy tree, and stereotypically trees are green. So what we would expect to see is in the green area here that we have high reflectance compared to the blue and the red. So let's check that out. That's exactly what we see. So more green light is reflected than blue and red. And incidentally, this part here, between about 650 and 700 nanometers, so actually around 675, is where chlorophyll absorbs light for photosynthesis. So here's our plant. It's green. It absorbs red and blue light for photosynthesis, and it also reflects near infrared, which we can't see, but that gives us information about vegetation health and its structure as well. So let's apply this now to coral, because I figure that it's a little easier to understand when we look at vegetation, because you're probably a little bit more familiar with what a tree looks like. We can apply the same process to coral though. And so one of the most interesting things with coral is that it has this signature 1, 2, 3 bumps, and then it's still got chlorophyll absorption because it has those zooxanthellae that photosynthesize. But just keep in mind this 1, 2, 3 bumps, because that's really useful. We can have a look at different features as well. So for example, we can see some sand. This is what shallow water looks like. This is what beach rock looks like. Now, the important thing about all of this is that it helps us identify different features in the image. So I'm going to jump over to Google Earth now and show you an example of some data that I collected on a field survey using my drone. So from Australia here, let's just zoom all the way into my field site here. As we come in, you'll see it popping in. Here we go into Heron Reef, all the way in, and these are some data that I've captured using that drone setup that I showed before, the little drone with the spectrometer attached to it. Now what it does is I'll fly the drone backwards and forwards in this sequential manner, and it's constantly taking measurements of light that's reflected and absorbed. And so while I zoom in all the way to the satellite data and I can't see if it's coral or sand or rock or anything, what I can do is to look at the spectral signatures. So at that particular point, I can actually say, hey, I know there's some coral there because it's got 1, 2, 3 bumps and it's absorbing light here for photosynthesis. I can also actually tell that that coral is probably quite exposed, so it's low tide time when that point was taken, because I've still got lots of near infrared reflectance as well. So I can do this on any one of these points. Here we go, a little bit more coral here too. And I can start to unravel the mystery of what's actually in those locations just by the way the different features reflect and absorb light. So what I wanted to do to finish up with some other fun examples is to have a look at some other things that I can see in my drone images as well. So if you look really, really closely, and I usually don't go out searching for animals, but it's really quite cool that you often get to see different features in your images after you capture them. So you look really closely, you can see some sharks, some turtles, and some rays. There's another ray over here as well, and there's a bit of shark that's just popping up there too. So really, really cool stuff. It's always exciting when I get my images back. So now that you hopefully got your eye in on that image, I wanted to see, I'll give you a moment or two to see if you can find any animals in this particular image as well. So what you see for context, this is still at Heron. So we have a channel on the left-hand side, which is where the boats come in. And we've got lots and lots of coral all the way over here on that right-hand side. So hopefully you've managed to see a couple of sharks in there. But this is also one thing that I like to do as part of my science, is to train a computer on what a shark looks like and get it to pick them out immediately for me as well. So hopefully you saw the sharks, and there's a couple of others in this image as well, but let's just zoom into this one. And you can see that they're now picked out quite easily. And that's based on training the computer what a shark looks like. And it's far faster to do it that way than to have me sit there and try to find everything in the image. And so just to wrap up, what I wanted to share with you is that drones are really cool. But what's more important is that you use the right tool for the job. And so in this particular graphic, you can see some satellite data on the left-hand side. You can see some underwater field photos in the middle there. And on the right-hand side, that's just giving you this feel for what the different types of data sets or sensors can provide for you. So satellites are wonderful for really large areas, but they don't give a lot of detail. Drones are better in the amount of detail that they give you, but not so good for really, really big areas. And then if you have people in the water or people on boats or sensors that are actually fixed to a point on the reef or anywhere out in the field, again, they give you different amounts of information. So perhaps more detail, but lower area coverage. There's always that trade-off. So while I work a lot with drones, they're not always the right tool for the job. But working out what is the right tool is the most important part. So it always comes from figuring out what the question is, what the problem is you're trying to solve, and then working out what sensor is going to best resolve that for you. So with that, I'll just leave you with my details. You can always contact me via social media, through my website. I've got lots of educational resources there as well, or shoot me an email as well. And then I might hand over to Dr. Ruchi.
Thank you so much, Karen. I think the first reaction that we had from everybody was, wow, that's so cool. It's like really cool. And this is something which we can only look at in National Geographic or Discovery, and look at your slides to see how you actually do it. So, Karen, a couple of questions from my side. I mean, how did you even imagine working in this entire field? What came to your mind and what inspired you to work for water?
I grew up in Canberra, which is the capital of Australia, down south, and it's a cold place. And I don't like being cold. And when I was younger, I thought that what I would like to do would be to move to Queensland, which is a northern state here in Australia, and to live in the tropics, warm. And so when I had saved up enough money to move out of home in university, I then moved up to go to a different university, and I would look through the prospectus of the university that had all the different subjects that we could take, and look at all the ones that had field work based on the Great Barrier Reef, because there were quite a few in marine biology and geography. And so I just picked all the subjects that would take me there. And I just ended up staying in that area because I really, really enjoy it. And I think it's super important to do something that you enjoy doing, because you've got a better chance of being good at it if you enjoy it in the first place.
Absolutely, absolutely. So, what kind of technology do you mostly use? I mean, drone-wise, are there specific platforms with specific camera that you require for this kind of work?
Yeah, so a bit of a range, to be honest, and it has changed a lot over the years. So I've been flying drones since 2013, and the technology has just changed hugely over that period of time. So the first drone that I had, I needed to attach my own camera to it using an underwear strap, and I attached that so that I was able to take photographs at the time. And then the next drone that we had that was able to carry a camera was huge. So, nearly as big as me, and it was so scary to fly. But it would only fly for 5 minutes because that's as much as the batteries would last at the time. But things have changed so much over the past 7 years. I've had drones that I've had custom built for the work that I do. And so drones costing up to, say, $50,000. But I also fly a lot with just standard off-the-shelf platforms. So the DJI, Phantom, Mavic. So yeah, a range of different options. And I tend to like flying the really small ones. So the smaller, the better, the safer. And I always think there's no point in flying something huge if you don't need to.
Do you have any camera specifications, like you need certain kind of camera for doing this entire thing?
Yeah, so it sort of depends on what you're actually interested in. So a lot of the work that I do, you can just use a standard camera, because the really good cameras nowadays on the Phantom, for example, the DJI drones, and a lot of the information that we see in the environment isn't just about color, but it's about the spatial arrangement of the way features look as well. So our brain can understand things like size, shape, texture, and we can get these things from these cameras. But having said that, I do use some much higher specification cameras as well. So I guess the most sophisticated camera that I have, it's a hyperspectral camera. It measures hundreds of different wavelengths, and it costs about 120,000 US. So it's crazy, and it's for the value it gives you. I'm not sure that it's actually worth that amount of money, but I was really fortunate to have a research grant that allowed me to buy something like that. But it's not necessary. You can do a lot with much cheaper platforms, and that's as much as I really try to promote. Do what you can with the cheapest version available.
Have you had any accidents or incidences where you lost a drone and it turned out to be an expensive project that way?
Yeah, so my most expensive drone, so that was the one that I said was about 50,000 US dollars. When the manufacturer came over to Australia from New Zealand to give us the drone, we were doing some test flights, and we had an incident that one of the propellers came off mid-flight, and it had 8 motors, so it did have redundancy, so it would have been able to stay in the air. But because we didn't know why one of the propellers had come off, because we knew that they were attached properly and it shouldn't have come off, we didn't know what had happened. So we decided that the best course of action was to deploy the parachute from this drone. But when you deploy a parachute, so motorbikes going past, when you deploy a parachute on a drone, all the motors immediately cut. So the drone will fall, and you just have to hope that there's enough time for the parachute to catch it. And the parachute largely did break the fall of the drone. It wasn't quite high up enough for it to fully float nicely down to the ground. So we did have an incident with that one. But yeah, that was That was unfortunately a manufacturer issue. Well, maybe that's fortunate because it meant that it wasn't anything that I did and it wasn't something that I had to pay for because it was an expensive drone.
So it's always advisable to have a parachute on the drone when you are doing like flying over the water.
Well, flying over the water is no different really to flying over land. If the drone crashes, it crashes. So it doesn't, by having a parachute on it, if it lands in water, your drone is destroyed, particularly if it's salt water as well. So most of the smaller drones don't have parachutes. And they're getting so much more reliable anyway. So, but certainly if you've got the really expensive drones with the really expensive payloads, that's when you start to want a parachute on them.
What kind of communication links do you need on the drone? Like satellite communication that you have is enough, or you need some more radio connections or telecom connections or something like that?
No, there's just the standard radio connection from the controller to the drone. Yeah, there's nothing extra special for any of the ones that I use at all.
And you don't do any of the processing while you are there? I mean, on the boats, you come back to your office and then do it?
Yeah, so I actually, when I'm on the reef, I will often be on the island, flying from the island as opposed to flying from a boat. It sort of depends on what site I'm going to. But no, definitely don't process anything on a boat. I will take out the SD card between each flight and download that. And that way, if the drone crashes, you only lose the data off that particular flight, not from the multiples beforehand. And usually at night or at the end of the day, I will run some basic processing just to have a quick check to make sure everything's going okay. And then I upload it to a server back in the office, and my server will do all the processing rather than do it off the Wi-Fi at the island. Or, sometimes I don't even have Wi-Fi access if I'm out on a larger boat on the reef or something.
Great. I'll take some of the questions from the class as well. Does the drone-based imagery or drone-based imaging work only on the clear and calm water, or does turbulence matter since you primarily work with the spectral signatures?
Yeah, so that's a really good question. It's challenging to work in marine and aquatic environments for those reasons. So if you are on a boat and you look over the side of the boat and you can't see anything because the water is so turbid, then the drone won't see anything either. It doesn't have superhero magic powers to get through high levels of turbidity. I'm really lucky on the Great Barrier Reef. The water quality is so very good, and we tend to fly at very low tide. And particularly at Heron, the tides can get so low that almost the entire reef drains away. So it's almost like there's no water there in the first place. So it's cheating a little bit, really, because it's the best conditions ever. But otherwise, if the water's deeper than 50 centimeters even, and if it's a windy day, so there's lots of ripples, then you won't be able to figure out if it's coral or algae or rock at all. It makes it really challenging.
Do you also work with underwater drones?
No, I don't actually. I do have colleagues that do that. I sort of decided quite some time ago that it was enough to deal with the above water drone. And when I'm out in the field, I might be out for a week or so, and my entire time is taken up with flying. I would not be able to fit underwater in at the same time. I just don't have that capacity.
Right. Okay. So Mayank is asking about the GitHub repository where the classifier code has been shared. Can you share it with us?
Not just yet. So the student that she has finished her masters, but she's in the process of publishing that, and so that hopefully she has that published within the next 2 months or so. But I'm happy to provide that you, Dr. Ruchi, and if you want to pass it on to anyone to stay in touch with that as well. Yeah. So hopefully it's accepted. It will be published in the Drones Journal in the SheMap special issue within the next 2 months or so.
Thanks. I wanted to know the benefits of using a spectrometer instead of a multispectral camera. Are those the same or they're different?
Yeah, so that's a good question. So something that's multispectral typically measures in maybe 4 to 6 wavelengths. So maybe it's blue, green, red, near infrared, and maybe something else as well. Something that's hyperspectral, which is typically what we call a spectrometer, is something that will make hundreds of measurements. So when I showed earlier the spectral signature curves, you could see a really nice line. And that's because there's hundreds of measurements all the way along all those different wavelengths that make it a nice smooth curve. If you use a multispectral camera, it would be jagged because you'd only have 1, 2, 3, 4, maybe 5 points. So you lose a lot of that information. But it's always a trade-off with everything that we do in remote sensing, in that if you use a multispectral camera, so only a couple of wavelengths, the sensitivity of those wavelengths is usually better. So we say that it has a higher signal-to-noise ratio. So the quality is better, but you just don't see fine differentiation. So it really depends on what the application is as to what the most appropriate sensor type is. I mean, I could talk a whole other couple of hours on that one as well.
So the spectrometer is very similar to the hyperspectral camera, is it?
Yes, so a spectrometer could be something that measures only on individual points, so those little spectra, or it could be an imaging spectrometer, in which case it captures an image based up of all the spectra. Yeah, and the same with, you can have a multispectral sensor and an imaging multispectral camera as well. So similar sensors, but whether or not they capture it as a pixel array or an image.
So taking it, let's say, to applications like forest, where you have multiple vegetation species that you have to classify, you can use your same analogy there as well and use hyperspectral camera on a drone to do that.
Yeah, absolutely. And there's many more applications in terrestrial environments than there are in marine environments, particularly in agriculture, using the same sort of technology. So the technology is actually more advanced in terrestrial than it is in marine, just because I think there's probably more funding in those spaces and it's more commercial interest, particularly with agriculture. But also it is a little bit easier because you don't have to deal with boats and water and those challenges as well.
True. Does the sun's angle also affect the image you take with the drone?
Yeah, absolutely. So there's a lot of things that go into our mission planning. So the first thing that we do when we're trying to figure out if we're going to go out on a field trip to the reef is to select those weeks of the year when the tide is low. And so that's when the coral is most likely going to be exposed. But we want to pick the times of the day when the tide is low, that is not at midday and not at 6 o'clock in the evening either. So there's a really nice spot between, say, 10 and 11 in the morning, and then between 2 and 4 in the afternoon. They're the best times, because when we have the sun directly overhead, then the really bright sunspot is in the middle of our photos. But when it's either earlier or later in the day, it shifts. So it's going to be at the edge of the photo. And then we can slightly tilt the camera angle to push it as far out of the photo as possible, so that then any of the analysis we do is going to be less tainted by any of the sun glint that we have on the surface.
Palak is asking, also asking about what is Bethos, Bethos.
Sorry, what was that one?
What is Bethos, Bethos?
Oh, I think that might be benthos. That's the bottom part, so under the water. So benthos might be the coral, the algae, the sand. Yeah, the different habitats on the bottom.
Okay. She's also asking, waves are very much unstable and the life in the water is very different. So we majorly have two options for mapping the corals, using aerial drones or underwater drones. According to you, which method is the most feasible and give better actionable data?
Well, that really depends on what you're trying to achieve, and it's the same sort of scenario that I showed when I had my friend Javier as the one person swimming along. You see how tiny he is in the area that he can cover. And underwater drones are the same, really. They can't cover huge areas. And particularly on a reef like Heron, even when the tide is all the way in, the depth of the water might be about 2 meters. So if you have an underwater drone and it's got a camera on it, it's always going to be about 2 meters away from the benthos and the algae and stuff, right? So if you imagine for yourself, you have your camera on your phone or whatever, and you're standing 2 meters away from something, you can see lots and lots of detail, but in a really small area. And that's the same as an underwater drone. So the above water drone, and the higher and higher you fly and all the way up to the satellite, is always going to see a much larger area. But that trade-off is with detail. So if you need to see every grain of sand on the reef, then your only option is going to be for something that's underwater. But if you need to see larger areas, then you have to forego the grain of sand, if that makes sense. So there's no one correct answer that in all cases the above water is better than the below water, because they just have different applications.
So Mayank has two related questions. Do you only do a binary classification of the corals since the bleaching is very fast? Or do you have multiple classes based on how good the depth in the red spectrum on the signature is? And also, do you have hybrid underwater acoustic sensor networks plus autonomous underwater vehicles plus aerial drones that help in such activities?
All right, I'll do those one at a time. It's a really good question. Do I only do binary classifications? No, and again, it depends on the information that I want to get out of it. A lot of the time, my main interest is in being able to detect the live coral, and that's the most important thing. And if everything else can be in another class, that's fine. So it would be binary in that sense. But often to get to that final binary, you need to be at something broader in the first case. So it might be I'm looking for algae, this red algae, green algae, brown algae, and you need to get all of those other bits and pieces out first before you can get the live coral, and then group everything up. So you just have live coral or else. But the other part of that question, like thinking about the dip in the red part of the spectrum, is also potentially indicative of how healthy the coral is. So instead of looking solely at is it coral or is it rock or is it sand or whatever else, we can start to look at measures of how much chlorophyll is there. And so it's a quantitative measure rather than a hard boundary classification. So we do that sort of work as well. It's a lot more challenging, but it's actually more interesting as well. I like that. I like doing that sort of work. Do I have hybrid underwater acoustic sensor networks? No, I don't maintain any of those sorts of things. There are those networks available on the reef, and particularly at Heron, because it's a really, really well-studied reef. But that's not the sort of stuff that I play in. I guess, everybody needs to work out the part that they're going to be able to maintain for themselves. And I do the aerial drones and the satellites.
Julie from Kenya is asking us, is there a use case for 3D models of the barrier reef in your research activity, or are 2D images adequate?
Yeah, great question. I might actually answer that with a slide. Let me pop this one up, and I can show you some cool stuff. All right. So when we capture drone images, not that one, when we capture drone images, if we're doing overlapping photography, that allows us to create three-dimensional models. And this is an example of a three-dimensional model that I made using drone photography. So we can do this either underwater, which is when I showed you the video before of Javier swimming with his rod and his 3 cameras, he was creating a 3D model underwater. This is a 3D model from the drone. And the concept behind if you're doing it from a drone versus if you're doing it underwater is exactly the same as photogrammetry without overlapping photos. And the cool thing about this that you see is this is part of the outer reef, which is a really similar area to the part that I showed you on Google Earth before, where I zoomed in and we could have a look at those individual points. So we actually see quite a bit of live coral around this area, and it's almost like this network of all the corals just really growing into each other, and it's really, really densely packed. But we also have these almost like crevasses, and I say that they're not actually very big. So, at most maybe about 30 centimeters where you can see the sand coming through here, and that allows water to pool in those areas. So even when the tide goes out, and these parts of the reef are exposed as they are when I created this mosaic and this model, these bits here, these white bits or the white sandy bottoms, there's still water sort of pooling in there. And what we're really interested in seeing on the reef as well is that how we can look at those areas where water may pool and how the temperature varies in those parts, and if that has an impact on the corals around it. So by looking at the hydrodynamics of the water and the water temperature and what that tells us about reef bleaching as well. So yeah, it's a really, really cool area that I'm interested in. There hasn't actually been a lot of work done on it, but it's interesting and fun as well.
So Palak is asking, in what other ways can we use the data obtained by underwater mapping apart from estimating live and dead corals? Can we use drones to estimate the population of a certain species in a particular area?
Species is really hard. I mean, conceptually, the idea potentially for genera, or more useful really and probably more achievable, is when we look at different coral morphologies. So where the branching corals versus the massive corals, the tables, the soft, that kind of thing. And how algal biomass changes over time as well. Species is just a really, really hard thing with corals. In some areas, so there's some areas of Hawaii, for example, on the reef where there's maybe only 4 species. So yeah, sure, you can map coral species, but when you've only got 4 to choose from, then that's an easier thing to achieve. But in a place like the Great Barrier Reef, where you really need to be looking down at the cellular level to see the difference between the species, that's just not something that's going to be achievable using remote sensing like this. And I guess the question is again as to of what ecological use that is to know that information in the first place, and is that of interest at the scale. So I would say no to species recognition, at least on the Great Barrier Reef, no to species recognition, but definitely yes to different morphologies. And I have a student actually working on morphologies for her PhD as well. So that's, working out different metrics that will allow us to measure those.
There is a parallel question a little down there. Is it possible to distinguish between coral species based on the spectral signature or shape and texture using the multispectral camera or the spectrometer?
No. Again, only like if you had a really small population and you knew in a particular area you only have 2 or 3 species, and those species do happen to be very, very different. Sure, but certainly not in any of the reefs that I've worked in.
And do the spectral signatures overlap? Like does coral overlap with rocks and sand, etc.?
Yeah, absolutely. And I guess you could sort of see that in the graph that I showed earlier. In some wavelengths, they overlap. So, it might be at 472 nanometers, for example. They're exactly the same, and you would not be able to tell any difference. And some other wavelengths, they're quite different. And that's always part of our analysis work that we do when we first start looking at the signatures. And what are the best wavelengths? And also, can we talk about the shape, not just the magnitude? Because, like I spoke about, those 3 little bumps for corals, it's that shape that's really interesting that helps us distinguish what it is.
Is the data from the spectrometer used to further train classifier for using the satellite images?
So at the moment, it's actually something that we're working on is how we can use the drones to better calibrate and validate the satellite data. So at the moment, I would say it's not something that we're doing particularly well, but definitely an area for research. I think, again, that's another thing that gets done a little bit better in terrestrial remote sensing than marine.
And what are the most difficult problems that you have faced during your project?
Oh, not enough time. I just don't have enough time to work on all the data. So particularly now, I think it's so easy to capture drone data, and I could be in the field for 5 days, and that gives me more than a year's worth of data processing. And I always want to go out. I love being in the field, and I want to go out again and again. But every time I do, I just give myself more work. And yeah, it's a nice problem to have, but it's definitely an ongoing challenge. And I guess that's also why I work with students, and the students doing their PhDs and master's projects as well, because they can help out with their projects and analysing those data too.
I'm sure you will get at least 4 interns from this course. Okay, so if you can fly at specific times of the year when the water conditions are suitable, does it limit how much you can learn about the Barrier Reef by seasons?
Yeah, so that's a good question. And yeah, so ideally you do want to be looking at different times of year. And particularly if you're sort of interested in, say, coral bleaching, for example, because we know that happens and that's based on water temperatures. If you're interested in algal dynamics, so when the times of the year when there's more algae, then yes, that definitely needs to be done at multiple times throughout the year. Corals, actually, they're so slow in their growth that that's not something that's so much of an issue. Except if we had a cyclone or a hurricane go through, for example, or some big event, you'd want to go back a little bit more frequently. But otherwise, they're really, really slow growers.
Do you prefer rotary wing drone or fixed wings, or maybe even hybrid VTOLs?
I fly rotary because I'm too scared to fly fixed wing. I have never flown. I don't know how to fly a fixed wing. I actually just sold my fixed wing. Well, my husband sold it for us last week. I've had it for a few years, never flew it. I have my license for rotary. And so, fixed wing's never something that I've gotten into. Part of the reason, aside from not knowing how to fly, but part of that reason is that the fixed wings just require so much space for takeoff and landing. Now, if I'm flying off the back of a boat, there's plenty of space to take off, but I have nowhere to land them. So that's a big issue, and that's always just been something that I just thought, well, I'm not going to get into that space. Now, the VTOLs or the hybrids are really, really interesting to me because obviously they give me that small area to take off and land. But the other part of them is that all they're going to do is capture more data. And I just, that's the data that I have. So I'm kind of happy just to stick the rotary at the moment. Yeah.
Yeah, once you have more interns from India and Nepal and Africa, you would probably use hybrid VTOLs.
Yeah.
Great. And is the barrier reef that you showed in the 3D, is it from the Finding Nemo movie?
Well, the Finding Nemo movie is from the Barrier Reef. Yeah, not the other way around. But yes, absolutely. That is the Great Barrier Reef. Yeah.
Yeah. So, anybody has any more questions to ask or anything that you would like to express? You can probably unmute yourself if something has not yet been addressed. Anyone? All right. So I think, Karen, we would come to the end of our class today. Thank you so much. I would like to really thank you from on behalf of all the students that we have in our class. We have about 80 students from all over the world, and it's been interesting. We have never seen your world, the world which you work in and live in, but we would really like to be there. Probably, at least try to do something of that sort wherever we are, if possible. And you spoke about the grant and the funding that is available. So in the last one entire week, we have seen so many people from Australia coming in talking about their work in conservation, which just means that Australian government is so generous about funding conservation projects, which is very nice. And so I would really like to thank Australian government also, because if you would not have put up such a work, we would not have learned from you. Thank you once again, and thank you everybody for coming at this hour in the afternoon. This is the end of our class number 22. We would not be meeting in the evening again. We'll be seeing you tomorrow. Thank you everybody. Goodbye, Karen.
Thanks so much for having me. Thanks everyone for taking time out to listen.
Yeah.